Tommy. So I'll just start this session. Before going deeper into what is Dr. Elephant and everything, let me just give a quick intro of how this Dr. Elephant came into picture and what were the difficulties we were facing because of which this Dr. Elephant bloomed and came into picture. And as you all know, as a developer, on a day-to-day basis, we are facing a lot of difficulties in tuning our jobs. So be it a Hadoop MapReduce job or a Spark job, the main thing is tuning and making it run end to end without any failures. So anyone can go understand Spark and write a code, but the major issue lies when they actually run the code with the whole set of data. So that is the place where the issue comes into picture. So for example, if I am going to write a code in Spark, so I'll be writing a Spark, and as a developer, I will be testing on a very minimal amount of data. So the actual issue starts when I start to run it on a very big data set. So there comes in the actual problem where I might not have enough resources for my job to run, or there might be a IO issue, or there might be a cluster inefficiency, or there may also be a memory overhead issue, or a mapper spill, reducer spill. All these things may happen, and because of which my job may fail drastically. So in order to avoid all these things, what we do is we jump into something called as tuning. So what we will do, we will write an application and we will run a job for our application to run. So when we do that particular thing, we do not know if the parameters we give is optimum or not. Will our code run in an optimized manner or not? All these things we will not be pretty much sure. So what we will be doing, first time when we run, it might take 1 to 1.5 hours. Second time, if you run the same job, may take 2 hours. Third time, it may complete in 15 minutes. So you cannot come to a conclusion like, okay, whatever we have done is correct or wrong. So have we actually optimized our job? We cannot tell. And seeing the job simply or seeing the code simply, you cannot analyze on your own, okay, it is just because of this persist cache issue, or this is because of this particular action we have the job has failed. So all these conclusions we cannot arrive immediately, so we'll have to do a lot of groundwork for each and every job to succeed. So on a day-to-day basis, there might be hundreds of jobs, and sitting and tuning each of the job will be a very big headache for all the developers, because we'll have to go deeper into it, keep all the parameters. If it is a Spark job, every time you'll have to go manually tune your executor memory, driver memory, your memory overhead. So first time you would have given 4 GB. Second time you will try increasing it. Third time you'll try reducing it. So this whole life cycle process makes your life very, very difficult. And at the end of the day, you feel exhausted doing all these things. So just to avoid all these things and just to make your life very easy, we have something called as Dr. Elephant, who comes and plays a role like you, and you can take the credit for what Dr. Elephant has done. So this is just an overview of what Dr. Elephant is. So before that, let's just see what all problems do you have when you try optimizing your Spark jobs. So either the kind of data may change when you actually run the job, or because of disk usage, it may fail, or connection issues, or memory spill, reducer spill. So you have a lot of things that might go in the background, because of which your job will fail, and you will never know it is because of this particular reason it has failed at this moment of time. So it may be one of the 4 parameters which is listed here, either inefficient queries or incorrect configuration parameters, or the way we use the Spark parameters, or concurrency. Because of very high concurrency also your job might fail. So these are the difficult part each and every developer faces on a day-to-day basis. It's not only with respect to Spark job, even your Hadoop, Hive jobs or Pig jobs, if you're going to do something, there also you will be facing this optimization issue where Dr. Elephant will be coming for your rescue. Okay, so Dr. Elephant was first time, it was actually found by LinkedIn. So they were the first people who worked for 2 years for Dr. Elephant, and in 2016 it was the first time Dr. Elephant came into picture. Not many people started using it because of some issues. Later they fixed it, and now Dr. Elephant is a open source, which is ready to be used by many of us. It is easily configurable, pluggable, and it goes around with many schedulers like Azkaban, Airflow, as well as Uzi. So Airflow, Uzi, and all they have added at a later stages. So what does actually Dr. Elephant do? Means it will run a set of heuristics or rules on top of your job. It gathers the metrics, and at the end of the day, it gives you a set of parameters with which you have to run the job. Which means first time I'm running my job with my own set of parameters. Dr. Elephant, what it will do after my job has completed. So Dr. Elephant will not interrupt during the time of your run. So once your job has completed, only at that point of time, it will come into picture. It will gather all the metrics or parameters or configurations you have used for your job, runs a set of heuristic rules which is already there. So there are a set of predefined rules which is already there. And on the basis of those rules, it will give you a diagnosed report. So it is similar to your doctor. You go to the doctor, you tell all your problems, and later he will prescribe you some medicines. It is the same way. So here you're telling all your problems, it gathers all the metrics, takes all the informations it requires, and finally it will give you a set of configurable parameters that you have to use for your job. If you are okay with all those parameters, you can schedule the job with those parameters from your next run, so that it will improve your cluster efficiency. The interruption of the developers will be very minimum, because we need not go and analyze each and everything. Instead, Dr. Elephant will do all these things. And most important thing is you can also write your own custom rules. So there are a set of predefined rules which we will be explaining in the later part of this slide. Other than that, there are also rules which you can write on your own as per your application. You can write for a MAPREDUCE job as well as for a Spark job. So for both these things, you can write the rules and launch your Dr. Elephant on top of it, so that those rules will also be applied to your code. So this is what Dr. Elephant basically does. It is a general overview, and later on we'll also be explaining the architecture, how it gathers the information from the Spark job, or how it gathers the information from the MapReduce job, what it does at the background, and how is it able to display all the metrics correctly. So we will be displaying, we will be explaining all those things in the later part of this slide. So this is just an overview of what Dr. Elephant is, and these are the key features of a Dr. Elephant. Main thing is it is pluggable and configurable, rule-based heuristics. So this is what I was saying. Predefined rules will be there. So you will be running those rules on top of your jobs, and it is easily integrated with schedulers like Azkaban, Uzi, Airflow, etc. And one most important thing is job level comparison. If you have two jobs, job A, job B, you have a dashboard, dedicated dashboard for Dr. Elephant, where you can put both of these jobs and try to understand like how each of these jobs performed, and what kind of metrics was used in those jobs, or how it can be improved. So those kind of job level comparisons is possible, and it basically uses REST API to fetch all the information. Okay, so these are some of the key features of Dr. Elephant. So are there any questions till now? Okay. If you have any questions, you can also type in the chat box. So the next slide will be presented by Anupriya.
So yeah, thanks, Aishu. So here in the next one, we are going to see about Dr. Elephant architecture. Aishu, can you please make it full screen? So here is the high-level architecture of Dr. Elephant. So at the top, you can see a job generator. So what it does is it will fetch the application from a yarn resource manager at a certain periodically at certain interval of time. Say for every minute, it fetches the information from the yarn resource manager. So once it gets the list of application, then depending on the type of application, whether it may be a MapReduce job or a Spark job, so for this, we have a separate fetcher. So they are MapReduce fetcher and a Spark fetcher. So what MapReduce fetcher will do is, it will start fetching all the information that it can get from an applications like it can get the application from the MapReduce job history. So what it does is it will query on top of the history server and it will get whatever metadata information that it can get from the logs. So similarly for the Spark fetcher, so it queries on top of the Spark history log that is been available for already completed application, and it takes all the related information from the application that is needed for the for the diagnostic rules. So after getting all the informations, so from the collected information, all the information that is being given by the application, we on top of this application, we will be running a certain rules on top of the data that is being collected from the history logs. So we have a certain predefined rules for MapReduce job as well as for a Spark job that is being defined in Dr. Elephant. So once we got all the information, the whatever rules that we have for a MapReduce and a Spark, it will run on top of the logs and it will save the information to the database. So Dr. Elephant, it directly it integrates with the MySQL database. So it also has a graphical user interface. So where whatever logs and information that is being executed and collected from the matrices, that can be visually seen by through a UI, which from the dashboard. So when the report is generated, it will be helpful for a developer to identify whether the particular application he has run that is being completed already, the particular job is safe or critical state. So based on that report, one can tune the performance of a job in a better manner. So this is all about an overview of how a Dr. Elephant and its architecture works. And next we will be seeing how does Dr. Elephant work. So as you can see in the simple diagram, we have an application and we have a thresholds and the severities defined. So let me explain in detail about this flow. So Dr. Elephant gets the list of all the recent succeeded and the failed jobs from the yarn resource manager. So basically whatever Spark job that is being submitted through a Spark Submit application, all the logs will be available through a history of service. So for a Spark, it will be having a separate UI where you can go and get all the logs related to each and every application that is being available. So similarly, once this metadata information of each applications like job counters, configurations and the task data are fetched from the job history, the metadata information will be helpful for the Dr. Elephant to identify and generate the report. So let me explain what is an overview of what is job counters, configurations, and task data. So in Hadoop, job counters is the one which provides a way to measure the progress of a job, or we can say like when we submit and Spark application, we have a number of stages that is being splitted across the executors node, and each and every stages is being further splitted into multiple tasks. So these tasks will be assigned to each and every worker node that is being assigned. So this job counter will help us to gather all the statistics about the MapReduce job as well as a Spark job. And it also helpful for validate if the particular data is being read and the data was written back to the HDFS or whatever database it is written back correctly or not. And it is also helpful for validate all the CPU and the memory consumed is appropriate for the job in a cluster nodes or not. And configuration, if you see, whenever we are submitting an application, we externally provide some of the configurations like number of cores, number of executors, number of memories and driver memory for a certain application that it processes a huge set of data. So based on the resource manager that is being available from the cluster, we allocate number of executors and cores for for the particular job that we are going to submit uh, through the application. So based on this, Dr. Elephant, what it does is it takes the metadata information that is being collected from the fetchers and it runs the heuristic rules on top of it. So heuristic is nothing but it is a process or approach, and it is a terminology that is being defined in a Dr. Elephant where it can be defined with the multiple rules for MapReduce job as well as Spark job, and it is used for providing a solution in a limited time frame. So these heuristic rules are ran on top of the data that is being collected from the yarn resource manager as a metadata information. So once these heuristic rules are ran, so it can be useful for identify how individual heuristics and the job as a whole perform, and then these are then being tagged with one of the 5 severity levels to indicate whether the potential of the problem and the performance of the problem of each application is safe or critical. So there are like 5 severities that is being defined in Dr. Elephant. We will see on detail of the severity in the later slides. And then we are going to see about how we can define a rule and how we can customize a rule in Dr. Elephant. Before going to next slide, if you have any doubts, you can ask. So, okay. Then we will see how we can define a rules in Dr. Elephant and what else we can customize using this. So defining rules is very simple in Dr. Elephant. It has an input, it has a logic, and it has an output. So input, as I have already mentioned about the counters and the task data. So these are all the metadata information of each application that is being collected from the yarn resource manager from the logs. So on top of this, we run some of the logic to compute a value. So after computing a value, we will compare against the threshold levels. So in a Dr. Elephant, we have some of the heuristic rules, and these heuristics rules will be defined, predefined with some threshold levels, and these threshold levels will be tagged to provide the severities. So there are 5 levels of severities that we have. So these severities will be helpful and to identify whether our application whether our each application of a Spark job is being safe or critical, or it needs any tuning or any optimization. So based on the report that is being generated, we can fine tune the performance in a better manner. And next is what else we can customize in Dr. Elephant. So as we say, we have a set of rules that is being predefined for both Spark as well as MapReduce. We can also customize our own rules by writing our custom rule. Say for example, we have a Spark application and we have a huge set of data, like history of data that we are processing for so long, and the job is so long running job, and we are finally we have an experience of tuning the particular Spark job by providing certain configurations. So these certain configuration, what we can do is we can write it as our own rule, and we can just enable by setting up the configuration parameters in the Dr. Elephant. So this is one of the way that you can create your own rule. You can set the already defined threshold levels. If you want, we can change the threshold level which is already defined according to our application, and it can be easily integrated with the new schedulers. So schedulers, as you all know, we have so a lot of workflow schedulers. So this workflow like Azkaban, Airflow, and Uzi we have in the Dr. Elephant. So what Azkaban is, it is a workflow scheduler, and it is a batch workflow job scheduler created at the LinkedIn to run their Hadoop jobs. And this Azkaban's first, it helps to resolve the ordering through a job dependencies, and it also provides an easy way to use to user interface, and also to maintain our task, and to keep track of the workflows. And similarly, we have a Airflow. It is another great tool for scheduling our jobs. It is also used for scheduling the data pipelines and ensures that the jobs are correctly ordered, and the dependencies are executed through a DAG workflow manner, which is a directed acyclic graph manner. And similarly, Uzi, we can schedule the Hadoop jobs as well as a Spark job. So it also has an UI interface. And third thing is we can enable or disable and extend to a new fetches. So already we have a Spark fetcher and a default. The Spark fetcher and the MapReduce fetcher will be enabled default. So if for the particular application, if you want to disable any of the fetches that is been available, we can go and do it disable, so that it will be extend to a new fetches whatever that has been available for the job. So whatever predefined rules and this enable thing is being defined in the Dr. Elephant, those are all very much easy for configuring and pluggable. So we can do whatever we need for a certain application that we need. So we can also define an application job types, and for example, if we have a MapReduce job, we can define it as a MapReduce job type. And similarly, we have a Spark, and similarly, we can Hadoop related jobs like big job, scoop job, hive job, whatever jobs we need, we can extend to search limits. So this is all about what else we can customize and how the rules will work in Dr. Elephant. If you have any questions, you can ask, or you can also type in the chat box. So someone is talking, or okay, for the next slide, Aishwarya will explain about the Spark and heuristics.
Yeah, thank you so much, Anupriya. So I will take over from here. So as Anupriya explained,
sorry for interrupting, Aishwarya. So Shiva Shankar has asked a question: is it only for on-premise or cloud? It is used for cloud as per we will also explain on cloud how we can integrate it. We can also use it for cloud.
Yes, it is also extensible in cloud. We also have a slide explaining, and also a small example of what they have done in cloud. So with which I think we'll be able to understand that part.
Yeah.
Thank you, Anupriya. So this is nothing but what all set of metrics, MapReduce heuristics, and Spark heuristics is predefined in Dr. Elephant is what we are going to see. I will just quickly walk through each of these terms because it will be very easy to understand that why we have heuristics for these things and what role does it play. So mainly used resources, wasted resources, runtime and wait time of a job. This is nothing but used resources is how much time does each mapper take, how much time does each reducer take, and what is the container size. Say for example, if I am having 4 mappers which is running at 5, 10, 15, 20 minutes, and similarly I have 4 reducers running at say 10, 11, 12, 13 minutes, and my container size is going to be 4. Then 4 multiplied by sum of the mappers and 4 multiplied by sum of the reducers will be the total consumption of resources by my job. That is used resources. And similarly, runtime would be the total amount of time your job would be taking for the entire end-to-end flow. So that is nothing but your end time minus start time in milliseconds will be your runtime. Wait time is nothing but if I am having some 100 mappers running in parallel, out of which 90 completed very quickly than expected and 10 is still running because of some issues, all the remaining mappers will be waiting until it completes. So that wait time, so all these metrics is being captured by Dr. Elephant, and you have a dashboard where you will be seeing the metrics overview separately so that you can understand how your job performed on basis of these resources. So how much resource has it consumed, what is the exact runtime, what is the idle time, means the waiting time of the mappers, and how much resources it has wasted. So that is nothing but the peak average memory. So there is one calculation where we compute the wasted resources. So all these things Dr. Elephant gathers and it will display it in the dashboard. Next, moving on to the MapReduce heuristics. Let me quickly give one-liner about each of these heuristics. First is the mapper data skew. What is mapper data skew is the amount of data when it comes to the mapper, is it equally distributed among all the mappers, or how my data is going to be distributed among the mappers. Sometimes what will happen, a few data, a larger amount of data will go into one mapper while other chunks of data will be distributed among the rest of the mappers. So that one mapper which is having larger amount of data will be processing for a very longer time, because of which at that stage itself I will be having data skewness. So that is my mapper data skew. Mapper GC is mapper garbage collection. So how much garbage collection each mapper has done. So that mapper GC. So mapper memory is nothing but how much each of my task has consumed and how much have I requested for each of the task. So that ratio will give you mapper memory. Mapper speed is nothing but is my mapper CPU bound, or is my mapper giving more amount of memory than expected. That is mapper speed. Mapper spill is nothing but when your mapper output is going to exceed the amount of data it gives. So that is mapper spill. Mapper time is nothing but the time taken by each of the mapper to run. So that is mapper time. So these are some of the important heuristics which we have to take into consideration, because these are the major issues we face when we actually run the data. It may be either due to mapper data skew, or it may be due to mapper spill, or the mapper speed, or mapper time, or vice versa. It may be all these things may happen in the reducer phase also, not necessary to be in the mapper phase. It may happen in the reducer phase also, the same set of parameters. So after all the mapper emits its data into the local, next is sorting and shuffling. So after sorting and shuffling, when the data enters into the reducer, is it entering in a correctly distributed manner, or there itself am I facing any skewness of data, and what is the reducer memory, reducer time, reducer GC. And the most important thing is shuffle and sort, because most of the problems happen because of shuffle and sort, because each of the mapper, it has to collect data from each of the mapper, do shuffling, sorting, and only after which it will be feeding into the reducers. At shuffling and sorting only, you would have seen in the Spark URL, after your DAG gets created, you have the stages, and few stages will be completely waiting. It may be because of this shuffle and sort buffer memory. So there are a lot of parameters because of this, because of which the shuffling and sorting phase also you may have some issues. So taking all these things into consideration, they have designed these inbuilt MapReduce heuristics. So you can select which all heuristics you want to apply on your data. So you may select all, or you may select specific, or you may write your own custom rules also. That is up to the need of the application. And similarly, we also have a set of Spark heuristics. So Spark executor load balance, Spark job runtime, Spark memory limit, Spark stage runtime. So it is nothing but how much time is being consumed by a stage, or what is the memory limit. So there, if you see, we will be defining everything in prior, the executor memory, driver memory, or the memory overhead, executor cores, driver cores, all those tuning parameters we will be giving before itself. And what will happen, we do not know the usage of all those resources. We will not be knowing if the resources or the parameters we have set is completely being consumed, or it is in waiting, or how far is it useful, or what all changes we will have to do so as to tune a good running job. So because of these things, we are defining the MapReduce heuristics and the Spark heuristics in prior. So these are some of the predefined rules which is already there, and it is already supported with Dr. Elephant. So are there any questions in these things? Okay, so I will move on to the next slide. Okay, so this is what Anupriya was talking about, how to customize your rule in Dr. Elephant. So if you are very much sure about what rule has to be implemented, and it is not one among these, then you can customize and write your own rules. Okay, so you can either specify it to a MapReduce application or to a Spark application. So this is one example where you can set these parameters. For example, say MapReduce. So the application for which I'm going to propose the rule is MapReduce. Give the name of the rule, path to rule class, path to rule help page, with which you will be defining the rules. Once you have defined these rules and your heuristic conf.xml file is ready, then you have to launch Dr. Elephant on this, so that the new rules will be applied on your data, and with which you can apply even more optimization other than the predefined and inbuilt heuristics. Okay, so this is how you can customize your rules in Dr. Elephant. Next, moving on. So this is the severity which Anupriya was talking about. So we have 5 levels of severity, and we have different colors for denoting the severity. It starts from critical, goes to severe, moderate, low, and none. So critical is the most critical job which needs attention, and we'll have to tune it, no other go. And none means your job is safe and all the parameters are tuned, and there is no need of tuning it anymore. Okay, so it says how severe a job is. So one of the most important things in LinkedIn, what they do is every day when they run their jobs in the cluster, they ensure that all the jobs are in green color, which means it has passed all the heuristics of Dr. Elephant, after which only it will actually run. So first time when you run your job, Dr. Elephant will not come for rescue. So first time you'll have to bear the pain. So it will run for hours, it will fail, do everything. Only after that, second time, all the failed and succeeded applications, it will take from the Spark history server, gather all the metrics, analyze those, run the heuristic rules on top of it, and then generate the results and the configuration parameters. And you can also set thresholds also. Okay, after this, if it goes, then put it in this particular severity. If it goes below this, put it in this particular severity. You can also define severity as well as scoring. There are also some predefined scoring which is then done. You can override that also. So this is about heuristic severity of Dr. Elephant. Going forward, we'll talk about Dr. Elephant's dashboard. So Dr. Elephant's dashboard, this is just an overview of how it will look. So this is how it looks. It is very, very user friendly. If you see, hello there, I have been busy. I looked through these many jobs today, and these many jobs require tuning, and some 3,608 of them need some serious attention. So all these things Dr. Elephant will say. And if you see there are 4 jobs or 4 application IDs which is being listed over here, out of which in the first job, if you see, mapper time is in some other color. It is not in green, which means it needs some attention. If you click on it, it will tell you like, okay, these are the parameters you'll have to set because of which it is failing, or it is taking more time, or it is consuming this much of resources. So it will give you all this information with which you can auto tune it, so that from the next time it runs only with the suggested set of parameters. Okay, so this is just an overview. You have a search tab, a compare tab, a flow history tab, job history tab, and a help tab. So this search tab is nothing but you can go and search for individual applications. With the compare tab, what you can do is you can just put 2 applications there, and you can try to understand that, okay, how one application performed over the other, or what all heuristics I have applied on this, or what not which heuristics have not applied on the below job, because of which it is taking time. So all these things I can make with help of this search tab, compare tab. Then you have the flow history, job history, and you also have the metrics overview as well as the heuristics overview, like whatever metrics we discussed just now, like what is the used resources, wasted resources. So all those graphs will also be plotted against your applications. So then after this, if you see, this is the Dr. Elephant's job page, which I said, and these are the heuristics which we have defined earlier, or these are the predefined rules, and I have already selected this so that these heuristics run on top of my data, mapper data queue, mapper GC, mapper time, and everything. You can see the colors of each of these heuristics which is already defined, and job type is Spark. It can also be a MAPREDUCE thing or a pick thing. So and how severity, so is it critical or it is not critical. One of the severity stages can also be defined. So all these things is integrated in one place. So in one place you will be able to view all these information. Next, this is one sample MAPREDUCE report which is being generated by Dr. Elephant, which tells you what is the mapper data queue, what is the mapper memory, shuffle and sort, mapper time, mapper GC, and mapper spill. So with this, you can also see that the colors are different, with which you can identify the severity or how important it is to tune that particular parameter. So for example, my mapper data queue means the amount of data that comes into the mapper, that itself is not evenly distributed. Some large chunk of data is falling into one mapper, because of which it is taking more time to compute, means it is definitely possible, because of which it could take long time to run. So it is my responsibility to go and tune. So Dr. Elephant will give me the suggested parameters with which I have to tune my job. So if you see there is a red color, so okay, something severity is there, because of which I'll have to tune the job. And similarly, you can check on each of this heuristics, the result of each of this heuristics, each of these metrics, and arrive at a conclusion that whether your job is optimized or needs more attention. Okay, so this is how the predefined inbuilt heuristics are there, and how you can write your own custom heuristics, and what kind of severities are there, and just overview of the dashboard. So after this, we have Spark integration, which will be taken care by Anupriya. So Anupriya will be taking this part of the slide. So are there any questions till now, or any parameters or anything which needs clarification? Okay.
So yeah, so let's see how we can integrate Spark in Dr.ELEPHANT. So there is a Spark feature which we can configure for extracting all the logs from the Yarn Resource Manager for each and every application that has been already ran. Like say for example, we have ran an application with some limit of time. So all the logs that is being collected and saved as a metadata information, and on top of this the heuristic rules will be run on top of it. So what it does is, so we have a Spark job and it may have a feasibility of failure based on the below reasons. Like say it has an unstable implementation, so we have a Spark code, we needs some tuning on the implementation of the logic that we defined in the program, or it may be due to unbalanced workload, and it may be also due to the limited allocated memory and using more than one or two cores per executor in the app. So basically all these issues will be a reason for a failure of a Spark job. So for identifying each and everything, we have a Spark heuristic, which is explained in the previous slide by Aishu. So load balancing in this Spark is default provided by the Yarn Resource Manager. Like load balancing is the one which helps to distribute the network and the application traffic across a cluster of the servers. So actually, it aims to optimize the resource use and maximize the throughput and minimize the response time and avoids the overload of any single resources that is being used. And it will also helpful for improving the responsiveness. So this kind of all the job failure thing that we can integrate using a Dr.ELEPHANT. So on top of this heuristic rules, we will get a set of report that using that report we can fine tune our performance based on the suggestion that is being provided by the Dr.ELEPHANT. So say for example, we have a job heuristic for the runtime that is being run for the application ID, and it provides it provides the certain memory usage and what is the reason for failure of the job, and what are the how many number of tasks that is being launched and how much of the tasks that is being successfully completed. So these kind of informations will be gathered based on the logs that is being collected from the metrics. And finally, it rates the job based upon the threshold level. So it takes into the job counter, it counts number of the metrics that is being collected, and based on the count whether the particular count is greater than the threshold level that is being predefined. So based on this threshold, we will be assigning the severity. So assigning the severity will takes into the counter of part based on the threshold values that is being defined in the Dr.ELEPHANT. So as already seen in the previous report, you can see based upon the severity with the different colors that is being defined based upon the threshold that is being collected using the number of job rules that is being ran on top of the heuristic report. So once this is done, it will be helpful for a developer for fine-tune their performance in a better manner, and it will also helpful for other jobs where we can just set the number of configuration and the parameters that is been available from the resource manager. So this is all about how we can integrate the Dr. Elephant with the Spark. So any questions on integration with the Spark? So okay, so in the next upcoming slides, Aishwarya will explain how we can integrate this with the AWS cloud using some simple example.
Yeah, thank you, Anupriya. So this is one setup of how we can integrate Dr. Elephant with the AWS cluster. So the steps are very simple, like how we do. We just have to get this Dr. Elephant in and launch the Dr. Elephant dashboard so that we will be able to view and monitor the jobs. So this Sparklens is nothing but it is also more similar to Dr. Elephant, which gives you suggestions on tuning. But we will be looking into how Dr. Elephant plays a vital role when we submit a Hive job through the EMR, when we are trying to do that before and after. So without tuning, what is happening, and with tuning, what we are able to get. So those things we will be seeing in the upcoming slide. So the way to integrate this is very much simple. It is not much complex of how to integrate this Dr. Elephant with the AWS thing. So next we will be just checking on testing Dr. Elephant for the Hive as well as the MapReduce workloads. So what I'm trying to do is I'm just creating a very simple Hive external table, loading data into it and trying to run some queries on top of it so that I will be able to analyze Dr. Elephant's performance. So I'm just doing select star with some filters. I'm just trying to put some filters. So you will be seeing that it is executing. So after it completes, what I am doing is I'm just launching the Dr. Elephant portal, with which I will be able to see that particular application ID's output on how it performed. So if you see, you will be seeing test mapper data skew, test mapper GC, all those things, out of which test mapper memory, there is some issue. Okay, so you have found that there is some issue with the colors because test others is green and test mapper issue memory. I feel that there is some particular issue. So what I do, I just click on top of it just to understand that what is there. So that particular thing will give me, okay, so these are what is a test mapper memory, some examples of test mapper memory. If you see below, it will give you suggestion. The problem indicates you requested large task memory set hive.test.container size is greater than 2048. So because of which the time taken to compute is very high. So this kind of suggestion Dr. Elephant will provide you. So after it provides this, you can take that particular suggestion, and I am doing this particular set hive.taste.container size is equal to 1024. So with which I have ensured that my particular query runs within that, and there won't be any severity or long time to run that particular query. Then again, I'm issuing that same query and launching Dr. Elephant. If you see, all the heuristic rules, whichever I have applied on top of that query, has become green in color. So which means that it has passed. There is no severity, and I'm good to go, and no extra suggestions is required. So sometimes what will happen, all the parameters or all the heuristics will not be in green. So there might be one or the issue, or it might be interconnected because sometimes if the core is large, so driver core is more, driver memory is more, so those things can also be tuned with the help of this without much of developers effort. Without developers effort, you can just try to understand what is the problem, what is the issue, and you already have the suggestions. So taking all those suggestions into consideration, you can arrive at a conclusion and use this, so that from the next run you will have everything ready, and your job will be running in a more and more optimized manner. So this is what we wanted to explain about Dr. Elephant. So if there are any queries, do let us know. Feel free to type in your questions also in chat box if you have any. Okay, if you don't have any questions, thank you so much for joining the sessions. And if you have any queries, you can directly write it to us, and we'll try to answer those questions. Thank you so much for joining the session.
Yeah, thank you everyone for joining the session.
Thank you, guys.
Thank you.
Thank you.